Creating and using views. Alright, so another database object to get familiar with in this video. This time, we're going to learn about how to access data using views. And of course, we'll also take a look at all the different flavors of views that are available to us in SQL Server 2005. So first here, let's take a quick glance at our outline to get you familiar with what we're going to be talking about in this video. We'll start off with the old introduction here, an introduction to views. I'll start with what is a view. We'll take a look at all the different types of views available to us. We have the standard view, the indexed view, and the partition view. And then we'll take a look at how each one of those types is intended to be used in SQL Server 2005. Then we'll jump right into the demos here and learn how to create views. We'll learn how to create each one of those different types of views and also modify them, of course, alter them and delete them. And then finally here at the end, we'll learn how to work with views. Specifically, we're going to take a look at how to modify data through views. So modify those underlying tables that the views are based on and how we can update them. Alright, so let's get cracking here with our introductory segment on views. I first want to get you familiar with what a view is. And in the database world, you're going to hear this referred to quite a bit, views referred to quite a bit, as virtual tables. A view is just nothing more than a virtual table. Well, what's that? Well, let's take a query, for instance. Let's say that we had a customer table and a region table out there, and we wanted to write a query to grab customers and their associated regions. What would we do? Well, of course, we would write a select statement, joining these two tables together, and then outputting whatever columns we wanted out of these two tables. And our results would be like all of our results when we, write a query and execute it. What would look like a table, a result set with rows and columns. And really, that's all a view is. A view is just a query. It's a query that we can actually store in the database. And that's why they're referred to as virtual tables, because of course tables actually store and contain the data, but views just contain a query that when executed, the query goes out and gets the data from tables and returns them back to the user. So that's why they're called virtual tables, because again, the result is the same. No matter if we're writing queries against tables or we're writing queries against views, we're still going to get data back in a tabular format with rows and columns. Now, some could argue that views are stored queries. What about stored procedures? They're just stored queries too, right? Well, that's not true, really, because stored procedures are a lot more complex than views because they can contain business logic and programming logic, error handling, things like that. Stored procedures can take full use of the SQL programming language, where views are just simply queries. They can be very simple queries, again, that just take data out of one table, or they can be very complex queries that join multiple tables together and aggregate data. So that's what views are. Now, we have different types of views out there to accommodate for different situations. We have standard views, indexed views, and partition views. And we're going to start off here with standard views. A standard view is just what we did over here. It's a query that's stored in the database that users are going to access using standard DML statements as they would against a table. So select star from view name rather than select star from table name. We use standard views again to combine and filter data from one or more tables. In the end, it's going to simplify data manipulation and results because we can target and focus on specific data and give users access to that specific data rather than, if you have a power user out there, you may not want to give them direct access to the tables because there may be a lot of convoluted fields in there. Then they'll have questions, and just overall, it's a lot more work. So we can really, make it easier on our users by giving them access to views and have them focus on specific data. And also, we can help ourselves out. If you have a very, very common query out there that you're constantly rewriting every time you have to do something, why not make it a view? Save yourself some time, and then you can just grab data from the view rather than rewriting that query every time. We also have indexed views, and indexed views are a great addition to SQL Server. An indexed view is really just a view with a clustered index on one of the columns within that view. Now, there's a big difference, and it's really an architectural difference here between an indexed view and a standard view, and that is standard views aren't stored anywhere. And again, it's just the query that's stored, where indexed views are actually, when you create them and you click OK to create your index on that view, it's actually going to compute and physically store the data within that view in the database. And then anytime that data is updated underneath the hood, it's also going to, update that data within the index within our view. And I'll show you on the next slide here what indexed views are good for, how we use them, why we would use them, so on and so forth. We also have partition views. And partition views is really a great way to scale out the processing of poor performing queries, right? What a partition view is here is really just a way of combining data from multiple tables either on the same server or across servers. Now, how we do this here is we do what's called partitioning. We partition our table up by horizontally slicing the data out of one table into multiple what are called member tables. So how do we do that? What's horizontally partitioning a table? Well, What that is, let's say we have a customer table out there and we have a million rows in this customer table. Well, what we could do is we could break this down into two customer tables, call it customer 1 and customer 2. We could put you know, the first 500,000 rows in one table, the second 500,000 rows in another table, and then we would write a view to combine those data from multiple tables into, of course, one result set where users would, again, query that view, and the view would take all that data, combine it together, and return it. So to the users, they wouldn't even know it came from two tables. So we have two different flavors of partition views. We have local partition views, and local partition views take data that are on the same server and combine it together. And we have distributed partition views, and these take data from multiple tables across multiple servers and combine them together. So we'll take a big look at partition views again, how we would use them, what they're good for, and I'll get a good demo going as well. One thing I do want to mention though is Microsoft is trying to phase out local partition views. They say it's only there, only support is really there for it in SQL Server 2005 for backwards compatibility. Really they want to phase it out because there's better ways of doing this, and that is of course just using standard old queries to access partitioned views or partition data on your local server. So I'm going to actually show you everything there is to know about distributed partition views, and really you could just take the logic here and apply it on one server rather than across servers. Alright, let's dig a little bit deeper into each of these types of views and take a look at how we would use them in real world scenarios, how you will be using them in real world scenarios by looking at some view usage here. First off, standard views. Standard views are just very easy to use for yourselves, for ourselves, for our developers, easy to use for power users, and even those users who are just dangerous where we want to give them access to the tables, but we don't want to give them access to every single column because we'll confuse them. There may be tons of columns in a table, and they may only need 2 or 3 or 4 of them for their, whatever they're trying to focus on. So we can use standard views then to simplify the results by focusing on specific data, giving our users only access to the data that they need to see, and that'll make their lives easier. That'll make our lives easier because they'll come to us with less questions on what does this mean, what does that do, how do we do this, things like that. Also, we can simplify security by controlling access through views rather than messing with permissions on columns and underlying base tables. We can just simply write a view, give them access to the view. So great way of simplifying security. Also here we can provide backwards compatibility during schematic changes or underlying structure changes on those base tables. And just to give you a quick example here on backwards compatibility, let's say that we have an old database out there with a lot of applications attached to it, but we wanted to normalize it because let's say we have an employees table, for instance, and it's one big honking table with all the columns you can think of in it, and we wanted to normalize this table because the data is getting really redundant, and by normalizing it we could save a lot of disk space, and we could really just save on the performance and everything. So what we could do is we could take this big honking employees table and we could break it down into an employee table, a department table, vacation times table, whatever you want to think of. We want to normalize this table, but we don't want to break existing applications. So what we can do is we can still make our 3 new tables, right, that are all normalized and all joined to each other. We have, again, our employee table, our department table joined together. What we would do is we would actually then when we're all set, in renaming these tables and such and designing them, we would create a view that had the same name as our original table name, only this view would take all that data and it would combine it together, and the structure, the results would be the exact same as our original table. Well, what that would do is, of course, not break any applications because they're still seeing the same things, but underlying the database is still performing a lot better because now it's normalized, and the new applications that access, our new tables can take advantage of just accessing the new structure. So it's the best of all worlds. So standard views, great for all 3 of these specific scenarios. Index views. Index views are great for, again, very slow running queries, very, very large queries that do a lot of work. So you're joining a lot of tables, you're aggregating a lot of data. Great for doing this because we can slap on an index on, one of our columns, put a clustered index on it. Now the view is stored, and anytime it's accessed, it happens a lot quicker. You don't have to wait for the view to process and return the results every time because it has an index on it. So it's already been computed and physically stored in the database. And that's what they're great for. They're great for queries that take a long time, return large results, and require a lot of processing. Another big positive to index views is the fact that it's still an index, right? So other queries are going to benefit from this index on our view and take advantage of that data. So a very, very big benefit here is not just, this index isn't just used for this specific view, but it's on this column, so any other columns or any other queries that reference this column are going to benefit from it as well. And again, as I mentioned earlier, updates are reflected in the stored data on this view. So updates can happen fine. You don't have to worry about recreating the index on the view or maintaining that at all. SQL Server handles it for us. Now we also have partition views, and again, partition views is a great scaling solution, one where we have very long-running queries, take forever because we have a lot of data in these tables. Well, this is a great way to take the data and partition it out of our tables, put them onto separate servers, and then we could create views that actually went and compiled that data from both servers together and return the same results to the user. So how this works now, I'm going to show you how the distributed partition views work here. What we need to do first is, say we have a big honking table out there again, say we have 1,000,000 records in this table, and we'll say we have a customers table. So what we would do is we would split that big honking table up into two smaller tables where, say, we'd have all the A through M customers here based on last name. The A through M customers in one table, the N through Z customers on another table, and then we take those tables and we put them on separate servers in the same database, right? This would be what's called partitioning our table up into smaller member tables. So instead of one big honking customer table, now we have a customer table on one server and a customer table on another server, both with the same exact structure. The only difference is we horizontally partition the table, meaning we partitioned it using a where clause by the data and put them into their own table, both on separate servers. And of course, I'll show you how to do that once we get into a demo here, how to take we have a big honking table, of course I've got one, and we'll split it up into two smaller, more manageable tables, put them on two different servers. And once we do that, the next step is creating linked servers. We have to link these servers together by creating a linked server so they trust one another, and we can write queries that access data on another server through one server. And that's the second step, so we'll do that as well. We'll set up a linked server. The third step is create the view. And what the view is, it's pretty much the same exact view with one small difference. This view over here on this side is gonna grab this local data, A through M, and then it's going to union the data over here by going through the linked server and grabbing the data through here. It's going to pull it back in here into this view, and then to the user's not going to see any difference. It's still going to see all the data because this view is the one that handles grabbing the data through both servers. Same with this side. If this user were to run the same query against this same view, wouldn't matter. It's still going to grab all the data because this view is going to do the same thing, just the opposite. It's going to grab all the local data, N through Z, and it's going to go through the linked server here and grab the A through M and pull it back over. So no matter what view user runs on either server, it's going to grab the same data. The benefit here, of course, is that now we have two servers doing the processing power. This server is just requesting to get this data from this server, so you're splitting it up. Theoretically, this will take half the time as it would before to run, one view on one server to grab all the data A through Z. When you have 1,000,000 records, that could take a bit. So, and you can even add more servers in the mix here. If we were to add another server in here, we could, again, it gets a little more complicated because now we all have to trust one another. We have to split up the data, maybe A through G, G through P, P through Z, something like that. But now, theoretically, you have a third of the processing time as it took before. So partition views, a great way to scale out the processing, especially when you've already beefed up your server to max potential. Everything's optimized. You can't really do anything more. Your only option is scaling out. And this is a very cheap scaling solution because it's really just takes more processing power than anything. Of course, cheap, that is, if you happen to have extra servers lying around. So, all right, now that we know how to use each different type of view here, and we know what they do, let's take a look at how to create them by getting into a demo. So let's fire up SQL Server Management Studio here by heading down to the Start button, on up to Programs, on over to SQL Server 2005, and right down to the Management Studio here, SQL Server Management Studio. We'll connect right up to our prod database here in Object Explorer. We're going to actually jump into the AdventureWorks database this time around to get familiar with how to create views. There's a lot of good test data in here that we can use to showcase these views, and a lot of tables to join on too. I'm also going to open up a file, a query that I threw together, a script I should say, that has a bunch of queries in them, called Creating Views. And we're going to hook this query as well, the script, right up into our AdventureWorks database over there in our production server. So let's start off here with a look at standard views. And creating standard views, very simple to do. Really, the bulk of the work here is just creating your query. So let's say we have a query here. Just to show you what this returns, I'll just highlight the query. This is, of course, going to return employee time. So we have employee ID, first name, last name, title, and then we also have their vacation and sick leave hours. So let's say we wanted to turn this into a view. Well, we could do it a couple of ways. Number one, we could use transact SQL, as we could use to create anything. And it's very, very simple. We just do a create view followed by the name of the view, and then as, followed by your query definition. And this, if we highlight it all and hit execute, is going to create a view. Now we can go up into our views folder over here, right click on our views folder, hit refresh. There it is, employee time. And now if we wanted to run this view, we could, just like we were to access the table, we could just write a select statement against it. Select star from, and I'm just going to go ahead and copy our view name up here, human resources dot v employee time. So if we highlight this code and hit execute, check it out. Same results. Only now it's a view, it's a stored query within our database that we can reference just like we would a table. Now there's actually a couple of ways you can create views here. You can do it graphically as well by using the query designer, and you can actually create any query using the query designer. That button is right here, design query and editor. That would actually just bring up this little query designer here. I'm going to close out of it though. And exactly, if you right click on the views folder here and choose new view, that's exactly what it's going to do. It's going to pop open this query designer, only instead of it as a window as it does on the toolbar, it's actually a tab up here. So now we can do the same thing. We can come in here and we can grab the contact table and choose add. And then we can grab the employee table and choose add. Now I personally like doing this stuff through code just because you write the code, you know what it's doing, it's a lot cleaner. That's one thing SQL isn't very good at, or I should say SQL Server Management Studio. It's not very good at writing clean code. It's very, very long. But it's a great, quick way to do things. So if you're in a hurry, you know, or you want to see how something is done, it's a very good tool. So, you know, use them both. But if we want to do this here, you can just simply grab the columns you want. So out of the employee table, we wanted the employee ID. What else did we want out of here? We wanted the vacation hours, sick leave hours. We also wanted to filter on the salaried flag and the current flag, so we'll put those in there. And then out of the contact, we wanted the first name and the last name. And did we get title? Oh yeah, we also wanted title out of the employee table. And now what you can do is you can come down in here. We can say what we wanted here. We wanted where salaried flag was true, so we can go over here and hit where the filter is and hit equals 1. We also didn't want it outputted. We just wanted a where clause, so we could cancel the output there. Current flag, same thing. We just wanted where this equals 1. And there we go. This should be the same exact query here, only we built it in the designer rather than in code. There it is. Same results, just in different order. So that's one way to do it. That's another way to do it. Both ways to create views, either using the designer or using SQL code. And standard views, again, very easy to create. Once you create them, they're stored as an object in the database. Now we can treat them and access them just as we would a table. All right, let's move on to some indexed views here. Now, remember, indexed views are great on queries and views that do aggregations and join tables together that have large amounts of data and just generally work with large result sets. So those are perfect candidates for an indexed view. There are a few rules we do have to abide by here when doing indexed views. The first one is we have to use the schema binding option when creating our view. And the reason being, and what schema binding does for us, is it actually ties this view to the underlying table schema and basically says, if any user or anybody tries to modify any of these tables in any way that it would affect this view, in other words, maybe they change the name of one of these columns or the data type in one of these columns, what would happen is whoever was making and modifying that table, when they saved it, they would get an error and saying, sorry, you cannot do this action because it's schema bound with a view. And it would, of course, probably tell us the view at that point. So very, very handy. We have to use it, and it basically means our view will never break due to schema, issues, structural changes within our base table. So that's one rule. Another one is if you are going to use aggregates inside of an index view, you have to include this count big function. You have to include it. Even if you don't use it, you may not need it. You have to include it in here. It's required for indexed views to function properly. Now, there are other minor rules you need to follow, such as you cannot reference any other views within your index view. All of the tables that you're referencing need to be in the same database as the one in which you're creating the view in. And there are many, many other minor rules, but if you create an index on your view, SQL Server will, of course, yell at you if you don't meet certain criteria, or at least point you in the right direction and what you need to do to fix it. So, back to the query here. What this does, this is actually an aggregation, and this is going to run through quite a bit of data here. It's going to basically take all of the bikes and give us, aggregate up, give us the total sum of total quantity sold for each bike, the total sales price, I should say, of each bike, and then also the total number of sales for this bike. So that's where the product subcategory ID equals 1. That means bikes here. And that's all we're doing. We're grouping on each name of the bike, and that'll roll all of this data up into a nice aggregation for us. And by itself, without a view, or without an index, I should say, you can see it took a little bit of time there. We waited about, a second and a half, 2 seconds. But that's because we're on a fast database server. And there's a lot of data to chunk through here. And it also may be cached because I've been running it a few times testing it out. But it did take a little bit of time. This is a perfect candidate for an index just because it does have so much data to aggregate here. So the first thing we're going to do, let's make a view out of it. We'll highlight all of our code here, hit execute. That'll actually create the view. And at this point, it's not an index view. Remember, we don't have an index on it. It is still just a view. So if we just run our select star here from the view, you can see that it still took a little bit of time. It took us a couple of seconds. So let's see if we can trim this up and make it instantaneous by putting an index on it. Now, there's also a few rules on the actual index that we're going to put on this view. Number one, the first index you put on a view has to be a unique clustered index. Number two, if you use a group by inside of the query within your view, then the clustered index must be that column, that group by column, or columns if you have multiple ones. Other than that, after that, you can put as many non-clustered indexes as you want on your view, and that's pretty much it. So those are really the big rules there. And you can also create your indexes either, again, using code here, using the create index statement, or you can just let's go ahead and refresh our views here. You can head right on down to our sales at all-time bikes here. You can right-click and choose new index, just as we did when we watched our video here on implementing indexes. Now let's go ahead and just use code here. I'm going to highlight the code, hit execute. It's going to run through and make that index, store it, store the view in the database with the data. And now if we refresh our index down here, there it is, our IX all-time bike sales index. Now if we run our query, hit execute, look at that. That was pretty much instantaneous. I could tell there's a little bit of a performance difference, and that's saying a lot, even for something that comes back that fast without an index, and we get a performance boost like that. That's saying a lot. So index views can really speed up your queries. I advise definitely if you have a view out there that is suffering in the performance category, try to put an index on it and see what happens. All right, let's move on down to partition views. Now, remember, I'm going to show you here how to use a distributed partition view because if you can do a distributed partition view, a local partition view is pretty much the same exact thing, only everything sits on one server. And also, as I mentioned, Microsoft is actually advising you not do local partition views because there's better ways of doing things now with partition tables. Now, back to our distributed partition view here. The first thing we need to do is create and splice up our huge table into little member tables, right? So take a look at our database here, and what we're going to do is we have, I should say, in the AdventureWorks database, we have the customers table, sales.customer. Here it is. Now, this table is pretty big. If I right-click and choose open, we're going to take a look here, and you're going to see that we're going to have quite a few rows here, 20,000 rows. That's pretty good. That's pretty decent size, actually. So we have 20,000 customers in here, and we're going to say that that's too many. We want to splice this up and put half of these customers on one server, another half of the customers on another server, and then we're going to create a distributed partition view to access all of the data. The only difference is the view will be a lot faster because now we have two servers participating in pulling and combining that data back and returning it to the user. Now, when creating your member tables, you want to make sure that the new tables you're creating have the exact same schema and structure as your base table here. Now, we're just going to simplify things. And, of course, I say that because in a production environment, of course, all your users are going to be expecting the same exact columns when we do this seamlessly in the back end. We make this change. But just to simplify things, I'm just going to strip out 3 of the columns in this table, of course, because we're not in a production environment. I'll make things go a little quicker. Basically what happens, we do a create table. We're going to call this customers_west. So sales.customers_west. And this one is going to be stored locally on our production server here, our sql2005 prod server. So we're going to go ahead first and create the table. And the first thing I want to mention here when doing this is the thing that makes distributed partition views works and partition tables work is a check constraint. You need a check constraint on the partitioning column. All right. Now what that basically means here is this is how SQL Server is going to figure out when we create these views. These views are going to know to grab the specific data out of each table. So what we're going to do here is we put a check constraint on our territory ID because we're going to say territories, our territory ID between 1 and 5 is all the territories on the west side of the world. So we put a check constraint on territory ID column between 1 and 5, meaning any data that comes in here must have that ID between 1 and 5. So we're only storing customers on the west side of the planet. Now, and then we just have a customer type in here. So just some basic columns here. The next thing we're going to do after we create our table, we're going to export the data out of our customer table. Of course, only that data where the territories are between 1 and 5 here. And just to show you, let me show you this territory table here. It is right sales territory. There it is, sales.sales territory. If we right click and open up this table here, I'll show you. Here you go. See, basically all the U.S. are 1 through 5, and then the rest of the world is 6 through 10. Although I should probably put Canada over here too. But you can see France, Germany, Australia, and the United Kingdom are on the other side of the world. So this is what we're saying by the west side of the world and the east side of the world. And here's the territory IDs, 1 through 5, 6 through 10. So that's what we're doing. We're splitting it up by that. And we just wrote a simple query here. We're saying insert into this new table, into these columns, customer ID, territory ID, and customer type, and then we're doing a select. So this is called an insert select into, because we're basically doing two things at once here. We're inserting data in this table by using a select statement from our customer table. And that's kind of what I'm doing right here, is saying grab the customer ID, territory ID, and customer type from our sales.customer table, where the territory ID is between 1 and 5. So see, it's nothing really complex here. We're just simply writing a query to extract the appropriate data out of here and put it into this table, and then we're going to do the other thing with the other table and put it on another server. So let's first do this here. We'll hit execute. Boom, there we go. So we got 8,200 of those 19,000 rows are now inside of our customer West table. So all of our Western customers are in there. The next thing we're going to do, and I'm actually going to save this, we'll create the views last. We'll first get all of our members tables set up on our on both servers before moving into actually creating these views. So let's head on down to our customers East table, and we're actually going to, again, I'm going to change connection here. We're going to head on over to our dev server, and I'm going to connect to it. Let's also get a connection going here in Object Explorer to our dev server. We'll just right click on our SQL Nugget 2005 dev, bump into Object Explorer here, and there we go. We still have AdventureWorks set up. Now we're going to go ahead and, of course, we got to change our database. There we go. Same table. Remember, same exact table, except this one's named customers underscore east. And the check constraint is ensuring that only customers that have a territory ID between 6 and 10 are placed into this table. So we're going to go ahead and hit execute here. There we go. Now we have the table set up over here. Let's also do the same thing, same query to put that data in here, only the difference is we're territory ID between 6 and 10. Same thing. Boom. There we go. And of course now we have almost 11,000 rows in this table. So now we have our table set up, we have our data entered into those tables. We can pretty much, we can either scrap those old tables, or we could keep those old tables in place. And what we could do then is put triggers on those tables. So if any data is put into them, we could then, of course, put them into the appropriate table in the appropriate database. So that's how you can, if you wanted to keep the same structure of that old table for data insertions to go into. But that might be a little management hassle. There's a ton of ways to do that, ton of ways to actually still work with updates and all of that kind of stuff. And people could actually still insert into these views, and it'll get filtered back to the right table. That's also where the check constraint comes in handy, because, and I'll show you here, as soon as we create these views, people can just update either views on either server, and the right data will go into the right table. And that's really probably the preferred way to do it. But there are tons of different ways to do it. And it's a good thing that we have all of these options. So now that we have our member table set up, we have our data in our member tables, the next thing we need to do is set up linked servers so both servers can see each other. And then our last step will then, of course, be creating these views. So to create a linked server here, let's go ahead and first create one on our dev server, and we're going to create a linked server to our production server here. So let's head on down to the server objects node, and within there you'll see a linked servers node. If you right click on here and choose new linked server, so pop open the linked server dialog box. It's very simple to create a linked server. You just type in the name of the server, so SQL Nugget / SQL 2005 prod instance from our dev server. And of course this is a SQL server. You also want to put some security on here. I'm just going to choose be made using the login's current security context, which means basically the user that's creating this must, of course, and any users requesting or running a query on that other server must have permission on that server to do so. So we're going to go ahead and choose OK here, and that's going to create our linked server to our production server over here on our dev server. And then we're going to do the same exact thing over on our production server, pointing at our dev server. So we'll expand server objects, head on down to linked servers, and choose new linked server. As soon as this fires up here, of course this is a SQL server. Name of that server is SQL Nugget / SQL 2005 dev. Security, same thing. Use the login's current security context. We'll hit OK, and boom, now we have our linked servers set up. And now both servers can talk to each other, and we can run queries against tables in one server from our other server. So that's kind of cool. Now let's head back on up to our first one here and remake a connection back to our production machine. Let's head on over there. Attached to our AdventureWorks database, and here's how it works. We're going to create a view called sales.vCustomers as first one here is select star from sales.customer_west. So basically what we're doing here is we're grabbing all the local data from our west table on our production server. Remember, our west table sits on our production server, our east table sits on our dev server. We're going to grab all the data from our local table, and then you need to do a union all here in order for this distributed partition views to work. And then select star from, and here's how you reference a table on another server. You have to use what's called the fully qualified naming convention, which is in the form of server.database.schema.object. So that's how this works here, and this is how this will work. And actually, just to show you here that we can grab all the data out of our east table, I'm just going to highlight this code and hit execute. It's heading on over there to the other server, into that database, into that table, and boom, there it is. There's our data. Now, let's create this view over here. I'm going to go ahead, highlight it all, hit execute. Now we have ourselves a distributed partition view grabbing the local data from that server and the remote data. And now let's head down to server 2 and let's do the same thing. We're going to, only this time, change our connection back over to our dev database here. Hit connect, change our database to AdventureWorks. And now, same thing. If we highlight our query here, hit execute, takes a minute, but boom, it's grabbing the data from the other server. Let's create the view on this server as well here. I'll highlight all this code, hit execute. Now we have the same view on both servers. Now no matter what server this view is run from, it doesn't matter because it's going to be able to see and grab both data from both sides. The difference is now that it's only going to process half of the rows on one server, half the rows on the other server. So we have a completely asynchronous process here between servers, which theoretically, again, cuts down the processing time in half. Now, if we go ahead and do a select star from sales.v customers, we highlight our code here and hit execute. See how fast that came back? It was virtually instantaneous here, and that's because both servers shared the processing load of that query, that distributed query there. Now, another thing, let's go ahead and switch databases. Let's head on over to our production database. Connect, change to AdventureWorks, run the same query. Look at that. Same exact thing, half the time, same results. We don't have any order bys in here, so the order is a little different because it's grabbing the data from this table locally first, then the other table, where on the other server it did vice versa. But same thing here. Pretty cool, huh? We could actually put an order by right on the end of here. Order by customer ID. Now if we do it, look at that. There's one. If we switch back to our other server here, dev, flip on over to AdventureWorks, hit execute, same exact results. Pretty cool stuff, huh? Now, again, as far as updating goes, inserting and updating new records and existing records on this table, the preferred method to do that would be just to have them update the view. Because you can do inserts and updates on the view as long as, again, the schemas are the same between both tables, which they have to be anyway in order to do a union. So we don't really have to do a lot of work, and it's pretty cool. And the check constraint, again, controls all of that. If you do an insert on a view, again, a distributed partition view, the check constraint will know, actually that's how SQL Server will know to put the right data in the right table on the right server. So pretty cool stuff here. Distributed partition views, again, more of an advanced concept, but once you get the hang of it, it's very simple to implement, and it's a great way to scale out and increase the performance of these views and also the performance of your database in general, because now anything else that touches those tables as well is the tables are a lot more manageable. They're in smaller chunks, and it's just, again, the data is just going to be a lot easier to access. Now, since we're on the subject of inserting and updating data and modifying data through views, via views here, let's just talk about this for a second. Now, there's actually not a lot of restrictions when it comes to modifying data via views, believe it or not. The only ones are really the common sense restrictions, such as, make sure that you're going to get yelled at through SQL Server if you don't supply data on fields that require it, obviously. Foreign keys, things like that. Other than the common sense rules, though, there's not a lot out there. You can pretty much update and insert data through views all you want. And that makes it an easy choice when, again, using views for security purposes, because there's not a lot you can't do with them that you can do with tables. Now, we're going to actually take the first view we made, our standard view here, and I'm just going to go ahead and run this. And we're going to update it. We're going to update this. How about employee ID number 3 here, who has 2 vacation hours and 2 sick leave hours? Let's update this employee through the view to only have 1 of each. So we'll just remember our employee ID there. We'll hide our results and head on down here. Here it is. Update human resources.v employee time. So it works pretty much the same. Just as if you're updating a table, specify your column names. We're going to update a view. Only our employee ID here is 3. So let's go ahead, highlight this query, hit execute. Boom, look at that. 1 row affected. Now if we head on back up here to the top, and once again run our select statement, let's take a look at employee ID 3. Look at that. 1 and 1. There it is. So again, you can modify data through views. Very simple to do, and there's not a lot of restrictions around it. So, excellent. Now, two other things we can do with views, of course, alter views. If we want to alter a view, very simply, you just use the alter command up here. Very simple alter command, and then if you want to change something, like let's say we wanted to grab the title, their personal title rather than their employee title, we'll just change this to the PC title, which is a person.contact title. Now if we hit execute, there we go. And let's run it here. See, and now we get, of course, Mrs., Mr., things like that, rather than their actual working title, their human resources title here. So just show you, very simple to alter views, just use the alter command, or you can even alter them in the designer, as I showed you earlier here using the query designer. You can just change them graphically as well. And then to delete views, very simple, drop view followed by the name of the view, and this will of course delete the view out of the database entirely. And if you don't want to do it in code, again, you can do that just by coming into the views here, right-clicking on your view, and choosing delete. Same thing. Alright, so in the CBT Nugget, we took a big look at creating and using views. We started off here with an introduction to views. What are views? What are the different flavors of views available to us? We took a look at standard views, index views, and partition views. And really, I just got you familiar with what each of those types are, some common usages for each of those types, when and where you would use them. And then we got into a big demo on each one of them. I showed you how to use and create standard views there with our employee time off view. We took a look at how to create indexed views with our all-time bike sales there. And then at the end here, we took a look at how to create a distributed partitioned view, which is a great way of scaling out your queries and your views, putting them on separate servers and having the servers share load. And at the end here, I just showed you simply how to alter and drop views. So I hope this has been informative for you, and I thank you for viewing.